Hello and welcome to a lesson on the Fetch-Decode-Execute cycle. Now I know that we have looked at the Fetch-Execute cycle before briefly, but I'd just like to spend a whole lesson on it, just a very short lesson, but just to go through it again because it is very important, and then maybe go through it in a little bit more detail, just to kind of fill in some gaps in your knowledge. So, Fetch-Decode-Execute cycle. Software, or programs, provide the CPU with instructions telling it what to do next. The software is loaded by the operating system into main memory or RAM, and the processor is continually fetching new instructions from memory, decoding them, and executing them. And this is called the Fetch-Decode-Execute cycle, and is basically the purpose or the job of your CPU. So if you remember from the previous lesson, this is a simplified description of what the Fetch-Decode-Execute cycle does. So fetch, the instruction is moved from memory to the CPU. Decode, the instruction is understood by the CPU. And execute, the instruction is carried out. And this process is repeated again and again. Now, we're probably going to go into this in a little bit more detail now than you actually need for the exam. But I think this will hopefully fill in some gaps in your knowledge and just give you a deeper understanding of both the Fetch-Decode-Execute cycle and all the different registers and parts of the CPU that are used at different stages during this cycle. So again, let's look at the fetch cycle in a little bit more detail. The address of the instruction to be fetched is moved from the program counter and placed in the MAR, the memory address register. This instruction is then transferred from RAM to the memory data register. At this stage, the program counter is usually incremented by 1. So remember, the program counter holds the location of the next instruction to be executed. So if it was pointing, first of all, at location 0, then it will hold the location 1, then it will hold the location 2 and 3 and 4 and 5. It will increase sequentially most of the time. However, sometimes the program executes a jump instruction and the program counter is changed to a totally different address, as in it doesn't just increment or increase by 1. So why would this happen? Well, think about your own programs that you write. You've got your ifs, your elses, your if, else, if, elses. You've got your subroutines, your functions, and your procedures. So your program isn't always just moving on to the next line of code, isn't it? So sometimes you need that to move and jump around as you're running a program. And that's really what a jump instruction does. Most of the time it'll just increment by 1, but sometimes that location will completely change depending on the code that's being executed. Decode stage. The control unit reads the contents of the memory data register. It checks that this is a valid instruction, i.e. it is part of the instruction set that the CPU is programmed with and can understand. If the program is not valid, then the program will crash at this point. Of course, if it is valid, we can move on to the execute stage, and here the instruction is executed or carried out by the CPU. This process may use the accumulator in the arithmetic logic unit and may involve fetching additional data from memory. So there you have it. Hopefully now you have a greater appreciation of the different stages here. We've got fetch, we've got decode, and we've got execute. And you can see there's all kinds of different components and parts of the computer that are involved in these different stages. And hopefully, by understanding the fetch, decode, execute cycle in a little bit more detail, you'll also have a bit more confidence when talking about things like the different registers, the control unit, the ALU, and you can describe them in a bit more detail in an exam situation. Hopefully, you'll have a very pleasant day. I wish you well in all your endeavors. Goodbye.